Okay guys, an evil snowman is dragging a teenager back to his cave, and we are going to be doing a free body diagram of that situation. We're going to do some calculations. So let's draw the forces involved. For one, we have the force of gravity, which is, force of gravity is pulling down. If you're ever on Earth, there's force of gravity. It's pretty easy. Because the teenager is being dragged across the ground, there is also a normal force pulling back up. Those are equal and opposite, because if normal force was winning, the person would be going up. If gravity was winning, the person would be going down. Instead, they're not going up or down, so we know that they are balanced. So now let's draw the other forces. We have the snowman pulling forward, and because that doesn't really fit any of the other categories for things, we're going to say that's force applied. And we also have friction fighting the motion, so force of friction. And in the real problem on the worksheet, it says you can neglect air resistance, so you don't even have to think about that. So what we have here is we have, we're going to write our two equations that go with net force problems. So one of those equations is always the same. F net is equal to mass times acceleration. We can write that every single time. The other one we're going to have to make using our free body diagram. So we're going to look for the forces that make up the net force. We have normal force and gravity, which cancel each other out because they're equal and opposite. That leaves force applied minus the force of friction. Okay, so we're gonna kind of keep track of what we do and don't know here. They gave us the mass of the teenager, so we know that. We know the acceleration of the teenager. So we're actually going to be able to solve for our net force. And they are asking for us to find the force of the snowman, so that's the force applied. We also know from the original problem, it says that the force of friction is equal to 26 newtons. So we even know that. This shouldn't be that bad of a problem. So first of all, let's go after our net force, since we know our mass and acceleration. So F net is equal to the mass is 70, and the acceleration is 0.8. So our total force, or net force, is 56 newtons. So now we know that for sure. So we know this guy. So now we can just apply that here. We have F net is 56 newtons equals, we're looking for our force applied, minus, and we were just given our force of friction. Some people struggle with what to do with math here. Well, you're not going to divide because we have addition and subtraction separating the different factors here. So we're going to add 26 to the other side, and we get 82 as our force applied. Don't forget units. I was just lazy and did it myself. 82 newtons is equal to your force applied.